Hey, good Wednesday night, Orbiters. It's the week of Christmas. How's it going? Merry Christmas to all of you. Welcome to the stream tonight. It's going to be a short one today. I'm going to keep it simple, keep it quick. I know we've usually been going about an hour, a little over an hour maybe on our weekly streams, but tonight we're going to keep it nice and chill. And let me make sure we got decent enough levels here. Yeah, so let's see here. Okay. Yeah, so I'm going to keep this probably about like half an hour tonight, maybe a little bit more, just not too much longer than that. We usually start at 8 p.m. every Wednesday if you're new with us, and we're probably going to ride until like 8:30 tonight, and I'll just call it after that. So I'm going to cut some sections out, condense some things, and we're just going to hang loose. Still talking about space. So if this is your first time ever watching one of our live streams here on the Orbital Alliance, first of all, welcome. If you're watching it live right now, or if you're watching it in the future on a replay on the YouTube channel, that you can, what you can do after every week if you miss it. Just grateful that you're tuning in. You want to learn about space, which is what we do here on the live stream and on the YouTube channel. We try to make sure that there are new things for everybody to learn about space, so that one day they can go to space, like exactly what I want to do. So hopefully you guys out there too really want to go to space as well, and you can learn a little bit something today. So let's keep it quick. Let's keep it chill. I wish I had some Christmassy vibes here for you guys, but I got to work on the stream quality for next year, I think 2022. So let's kick things off. A couple of things. One, we passed a really big subscriber milestone. I think we did talk about it. We passed 256 subscribers, I think, as of right now, which is amazing. For those of you who are subscribing to the channel, I'm really, really, really grateful. We're going to be coming up on the 1 year mark for the Orbital Alliance existing, which is, I think, January 8th, January 12th, something like that. It's like early January. So I'm going to try to prepare some things to celebrate the anniversary of the Orbital Alliance being alive. We've continued to grow slow and steady, hit a little bit of poured some gas in the fire here at the end of the year, which is awesome. I think we're going to be set up for a really great 2022. We can talk a little bit more about the next year plans and the goals next week, because I'll be live again Wednesday next week. But I'm just kind of bringing to the attention here that we've been doing really well, and I'm just grateful for everybody who is investing time and their subscriber clicks here on this channel. So grateful for you all for sure. So typically each week I do a featured Funko Pop, which I've got behind me. We got a whole collection of Funko figures behind me, and I just absolutely love featuring one. So in the spirit of Christmas, I'm going to feature here a brand new one courtesy of my friend Josh, who tunes into the stream every week. So thank you, Josh. But we're going to feature Emperor Palpatine from Star Wars. He's got the wonderful lightning bolts coming out of his fingers. And the reason I'm choosing this one tonight is because it's the week of Christmas. And sometimes you can't always celebrate Christmas. You got to celebrate Sithmas, which is a Star Wars reference to the Sith, Jedi versus Sith. And he's a Sith, so Sith Lord. So Merry Sithmas, Emperor Palpatine, Funko of the week right there. So there you go, Josh. Cheers to you, man. Yeah. So what do you guys got going on for Christmas? Who's celebrating out there? It's coming up this weekend. We saw some family last weekend. We have plans to see family this weekend. Gonna be super fun. Um, yeah, it's gonna be good. We're having some fun with my family. We have a 2-year-old, so she's gonna be experiencing Christmas kind of for the first time, even though she's been through 2 other Christmases. This is the first one she's really been conscious for and really like kind of aware of what's going on and learning all the different things, what presents are, and the snow and reindeer and Santa, all that. So she's kind of getting a vibe. So keeping us real, keeping us fresh. So we're we're having a lot of fun doing that, and we're preparing her wonderful Christmas present of a brand new room for her in the house. So we're switching rooms to make sure she's got a bigger room for all of her stuff, and it's gonna be super fun. So we've been painting and preparing that for quite some time. So gonna be awesome. Hopefully you guys are having a great Christmas week and your work schedules are keeping you stress free, and you're gonna be riding into the weekend, Christmas Eve on Friday, Christmas Day on Saturday. Just relaxed and at ease. And hopefully you guys are all staying safe from COVID. All that stuff has been rising up this week, and just hope you're all well. But yeah, on to space stuff. So we usually talk about space news at the beginning of the channel. Oh, hey, Mom. What's up? Thanks for tuning in. I see your smiley face. So smile back. Always smile for your mom, everybody. Yeah, so space news coming up. I've been talking about the James Webb Space Telescope quite a bit here on the stream in the past few weeks. But the James Webb Space Telescope is kind of the successor to the Hubble Space Telescope, which is infamous for delivering beautiful imagery from deep space and all kinds of deep galaxies, measuring the age of the universe. I mean, it's for the last 30 years, it's been quite the workhorse. But the James Webb Space Telescope is going to be launching soon. It's been this wonderful thing to follow because it's been constructed for over 10 years. It cost $10 billion. It's the most expensive thing ever to be launched into space on one rocket. And it's going to deliver a lot of groundbreaking discoveries. It's going to be amazing. But the thing is it's been delayed for years. The launch has been delayed, I think 4 years, at least 5 years going on. But they've been scheduling it for this month, and it got pushed back, couple days, problem here, problem there. And they were going to launch it on the 24th, on Friday this week. Then they said, hey, there's bad weather in the forecast, pushing it to Saturday, no earlier than Christmas Day. So everybody's really excited for the James Webb Space Telescope to be launched on Christmas Day. It's going to be a wonderful Christmas gift for everyone who's into space. So be sure to tune in to NASA and their live stream feeds so you can watch the launch from, I believe it's French Guiana. I don't know how you say that exactly, but it's down in South America, and they're going to launch the James Webb Space Telescope up there, and it's going to be awesome. So perfect Christmas present for all of you spacers out there, and really, really, do your extra work to send good vibes on there so this thing doesn't have a launch failure, because it would be a really, really huge mishap if that were the case. So hoping for the best, but pretty good space Christmas present. And I'm going to limit it there for the space news this week and just kind of keep moving on. So what I wanted to do tonight was kind of give a little bit of instruction on how to look at the space station. We talked about that quite a bit on the stream. And if you've seen any of the videos on my channel about the space station and space station sightings, solar and lunar transits, where the space station goes in front of the sun and in front of the moon, I've done a lot of that. You guys have seen it. But I thought I would go a little bit, spend the next 20 minutes just explaining how you guys can see not only just the station itself, but how you can find a transit, because there's some really good free resources out there for you guys to do that yourself from wherever you are. Cool. So I'm going to jump in here. I'm going to prepare some. Let's start with sightings. Those are easier. And you can see these. I'm going to switch over to my screen share. Sweet. So there's a million resources for this. There's no one way to do it. But if you want to see the International Space Station from your location, wherever you live, wherever you're located, you can basically see it from like 90% of the Earth. Basically, the polar caps are probably the worst place. You can't really see the station. But the station's orbit, kind of changes and augments, every now and then. So it's not always in the same spot all the time. It moves. So you might get a couple weeks in a row where the station is going by your house very frequently, a couple times a day. And then the orbit changes a little bit. Then you lose it for a week or 2 or 3, and then it comes back, and you got to get waves of it. And the space station is only visible at dawn and dusk. So either just at sundown or sunset or sunrise, or just after, kind of in those first few dark hours, either on either end of your day, because it has to. You're only seeing reflected light. The space station doesn't emit light. It actually is just reflecting, because it's just a bunch of metal tin cans up there and solar panels just bouncing sunlight back at you. So it can't be behind the Earth in the shadow to cast light back at you, because it's in the dark. So, and you also can't see it in daylight because the sun's way too bright and this thing is way too small. And of course, if the sun is the station is between the sun and you're not going to see anything at all anyway. So you're looking at kind of the sides of your day. So you have sunrise and sunset. Those are going to be the best times to see it. And the type of sighting will vary from each pass to pass. And for clarity too, the space station typically has people on it, and right now I believe there are 10 people on it from all the different countries. The space station was built by several different countries, and I'll see you in the chair. Poor Santa. What happened to Santa? Oh no ISS by the North Pole. Okay. Good point, Kayla. That's hilarious. That's true. Santa will have to travel a little further south to see the space station. But hey, on Christmas he gets to go everywhere, so I suppose he's going to see it more than anybody. So I think that dude's just getting greedy. He just gets to see it all the time on one day of the year. So anyway, so the space station has been built by a cooperative of nations from around the world: United States, Russia, European Union, Germany, France, Italy, Japan out there too. It's there's a whole Canada. There's a lot of big players that have built the space station, and it's traveling at 250 miles above the Earth at about 17,500 miles per hour. So it's fast, which puts it in at about 16 circles around the Earth every single day. Lots of chances to see it. And there's some times of the year that are better than others too. So you could see sometimes up to 4 or 5 passes in one day from your location, if you're lucky, kind of in peak seasons. And sometimes it's just 1 pass a day, at others. So kind of depends. But what I would recommend here is to go to a site like spotthestation.gov, or it's spotthestation.nasa.gov, which is NASA's official space station sighting opportunity tracker here. And it's really easy to use. This is free, of course, so you can just go to it on the website, go on your phone. One of the things you can do is download an app as well on your phone. There's a bunch of them that are for free. I use ISS Detector on Android. I don't know if that's available on iPhone because I don't use an Apple device, but that's free. Gives you all the information you need. But I kind of want to talk about how you can read that information. So let's look here. So I'm going to try and scale this up if it'll let me, so it's easier to see for your guys' window. So perfect. So it basically shows you a map and it asks you to click where you are. So I'm just going to pretend, let's say I live in Washington, D.C. in the United States. I don't, but you can zoom in and it gives you these kind of click points, which sort of hone you in on a location. You can enter your town here in the portion here, but I'm going to click here and slowly click to the circle that's closest to D.C. because that's where I want to look and maybe see the space station. Maybe I'm traveling there. And you get closer and closer, and then eventually starts giving you these points, and you can click one. So let's pretend, let's see, what is this one? Arlington House National Memorial, Arlington. This is just Washington, D.C. right here. Then you just click sighting opportunities, and it gives you a bunch of information in the form of a chart. And you just kind of need to know the basics on how to read this to know exactly what to look for. So first of all, it gives you this whole list, and I'm just going to scroll here. These are the next few passes going all the way up to January 4th. It's December 22nd today, so it's giving us passes from yesterday. There's one today. Was one, actually. It's in the past. So 3 passes that have expired and a bunch coming forward here. So let's show you how to read this. So if you're in Washington, D.C., like we have here, there's some passes coming up. So let's look for the next one, December 23rd, Thursday. That's tomorrow. I can already tell you right away, this is a pass not worth looking for. Because some of them are just so short, they're not worth it. Or they're really low and you can't even see it, even though it says it's actually happening. Or others are just better. Some are longer and they're right above you and they're really bright and they're good to see. So Gives you the date and the time. So I'm going to kind of highlight what I'm looking at here, which is, perfect. So 4:53 a.m. This is going to be early. And right now, at least in the United States, the space station passes are happening in the morning. Those do shift into the evening, and they go sometimes in both the morning and evening. Obviously, it's better to be in the evening because you're just awake already. Not a lot of people probably want to wake up at 3 in the morning or 4 in the morning to see a space station pass. I've done it; it's worth it sometimes, but you really gotta, put the effort in to get outside and see it. But here, let's look at the next column. It says visible. So this gives you the amount of time that the space station is visible to you in your location. So in this case, this is less than 1 minute. So probably not worth wasting your time getting up at 4:53 in the morning to see something that's available for less than a minute. And it doesn't even specify how long. It could be 30 seconds. It could be 59 seconds for all you know. It could be 10 seconds, and that's just not kind of worth looking at. But that's helpful to know. Typically sightings max out at about 6 minutes. So space station will go from horizon to horizon, 6 minutes. Those are kind of ideal. You can see there was one on Tuesday, yesterday, 6 minutes. That's a really long one up there. The next one is maximum height. And what this refers to is kind of the invisible sphere that we kind of have drawn up for ourselves in the night sky. It's kind of like a dome. And you can measure all of those heights and angles in degrees. So the sky is divvied up into degrees. Basically from the horizon, if you look all the way up to the zenith, which is the point straight above you, they call it the zenith, is 90 degrees. So the single point above you is 90 degrees. And if you start lowering in any direction, like if you extended your arm and pointed it all the way up, you could count a degree and then it would add up from 0 at the horizon and all the way up. So halfway would be 45 and then 90 degrees straight up. So this is going to show me that at 12 degrees is the maximum height. That's really low because most of the time 10 degrees is the lowest the station will be. You'll never really see it at any lower than 10 degrees. So this is about the minimum you can see. It's actually kind of a unique sighting, to be honest. I feel like it's not typically this low or this short. So 12 degrees, that's about, here's a rule of thumb. Your fist at arm's length to your perspective is about 10 degrees. So if you look at the night sky, hold your hand out at the horizon, one fist height, you're about 10 degrees. I found that maybe is like a little bit less. You could kind of overcompensate a little bit more and it'll kind of give you a good estimate. But 12 degrees. The next one, it says appears and disappears, the next two columns. So it gives you the height in degrees in which the space station will appear in the sky, and then height in degrees on the other side of the sky where it will disappear, where it will no longer be visible for you. It also gives you the direction. So let's look at the appears really quick. So 12 degrees above east, northeast in this case. So what that's saying is if I were to look east to northeast, and you can download a compass app on your phone if you don't know directions, look east, northeast. So that in case that's like a little bit, look east and then go to the north a little bit. That's a little bit higher. 12 degrees. So a fist and then a little bit more. It's going to be super low. And then it says 10 degrees above east, northeast. So it's basically just traveling downward a little bit. It's going to appear at 12 degrees and disappear at 10. This is probably the shortest sighting I've ever seen actually on one of these. Just not even having seen it with my eyes, I can just read the information and tell you that's going to be a very kind of worthless event, to be honest. So don't waste your time if you're in DC watching this. Let's find one that's a little bit higher. It gives you a little bit more exciting information. A lot of these are short. Goodness. Okay, 1 degree to let's go to the bottom. January 4th, Tuesday, January 4th, 6:30 a.m. This is gonna be a 6-minute sighting. That's ideal. That's what you want. Height, maximum height of 46 degrees. So that's about halfway up towards the peak of the sky above you. So solid sighting. The maximum is about 89 degrees, 90 degrees. I think they typically don't really give you a 90 degree because there's only one point. There's no direction that gives you 90 degrees because it's the pinnacle, the peak of it all. So 46 degrees going up as the maximum. So it starts at 13, super low. It's going to create an arc in the sky. And you kind of can see this little dome here. I'm going to zoom in or scale over. Well, let me... It's not going to give me a scroll wheel, is it? Let's click this picture. Here we go. This is a good visualization. Instead of me just like pointing in my room here. So let's pretend. So here's you. Here's a person down in the bottom of the screen. That's not going to scale up the picture for me. If you're looking up It's over here on the left. This little dot here appears at 10 degrees, super low in the sky. And you kind of imagine this sphere, and you can imagine incremental measurements all up along it that give you degrees all the way up to 90 at the top. And then the max height is halfway through the arc. It will appear as an arc. It won't appear as a straight line, as it's moving. It'll arc across the sky. So peak, in this case, in this demonstration, 66 degrees. It's right about here, and that's going to finish its arc in this arrow direction as it disappears 31 degrees in the air. And the reason why it disappears at different heights typically is because of the Earth's shadow. It's going behind the Earth. It's going into the shadow. It's not reflecting light anymore. So in this particular case, 31 degrees in the air, the Earth's shadow, everything to the right of that is darkness. Everything to the left is the space station is like basically on the side of the Earth, able to reflect light still. So let's go back to our description here for January 4th. Zoom it in here. Hey, this is great. So 46 degrees, about halfway up, appearing at 13 degrees northwest, disappearing 10 degrees. So it's going from horizon to horizon pretty much, which is a pretty complete sighting. That's good. It's not being interrupted, whereas the other description was giving you kind of like a, hey, it's ending at 31 degrees. It's sort of getting chopped at the end. Not the case in this one. So pretty cool. That's kind of it. Another value to be aware of if you're looking at sightings, a lot of apps will give you this, is the term magnitude. And what magnitude stands for, or what it means, what it represents, is the brightness of an object in the night sky. And magnitude is measured in a number, a positive number or a negative number. It's kind of like a scale. And you got to think of it as like a vertical scale where positive numbers are lower in brightness, and negative numbers are brighter. It's backwards, kind of, so to speak, but it works. So if you look at it, it might give you a number like, hey, the magnitude for this station pass is minus 2.3. It's a solid pass. It's visible for sure, but it's not the brightest it can be. Maybe tomorrow's is going to be 0.4. So it's just below zero. It's a positive 0.4. That means it's going to be pretty dim. But if it starts going up above zero into the positives there, I'm going to throw back my camera so you guys can actually see me. So if you have a scale, maybe zero's in the middle here, and it drops to 0.4, that's pretty low. But if it's minus 3.3, it's going to go higher. That means it's brighter. And I think that typically the brightest passes are minus 4.4, minus 4.5. So if you see minus 4.5 magnitude, get outside and see it, because it's going to be super bright. It's going to be ridiculously bright. So definitely worth that. I wish they included magnitude on NASA's page. My phone app includes it. Maybe I can show you guys on the camera here. Let's see what we can do. The app I use is also really helpful because it gives you a live map where it actually shows the station on the planet Earth map, and then you can actually track it. Let's see. So like right now, the space station is going over Japan, literally. Oh, the Sea of Japan. Let's see if you guys can see this. Yeah, see, there it is. And that little green circle around the space station is where you can see the space station from the ground. So if you're in that circle in China, in Korea, in Japan, you can see the space station right now. Weather pending, of course, but you want to be in that green circle, and it's constantly moving. So if I zoom in a little bit more, you're going to see the space station is going to be speeding towards Japan. So I'm going to hold it up here. See, it's like sliding across. That map is updating, and it's showing it. It's in real time. Sorry, I'm holding this pretty crooked here. And eventually you're going to see the landmass come up. Japan, mainland Japan, right there. And this is the power of the apps that you can use. NASA's site is good. It gives you the core information. You get way more information. So the space station is literally approaching the coast of Japan right now as we speak. Pretty cool. Hopefully someone out there in Japan is watching and is able to go outside and see a really epic space station pass. So there we go. Let me show you what else I can do here. That's going to give me an ad. I don't want to see an ad. It is free, so there are ads. So let's look here at the front here. See that top pass gives you kind of in these blocks. It gives you a whole different bunch of opportunities. Those are the ones that are visible for my area. But the top one says magnitude minus 3.7. That's pretty bright. Height of 66 degrees. And that is tomorrow morning, December 23rd at 5:25 a.m. But it's going to be cloudy, of course. So I'm going to miss that one. But it also gives you a little bit of there's an eyeball there. and the eyeball is telling you, yeah, it's bigger. It's a big eyeball, definitely bright and visible. See, that next one is a smaller eyeball. Probably not able to see it because it's magnitude 0.1. It's a positive number. It's going to be pretty dim. But the next one is huge, minus 3.0. That's bright. And it's also giving you a 24-degree max height. Josh, I just see you join the chat here. Well, I'm going to relive the Funko moment for you because I'm going to be on here. I'll be on here for a few more minutes, but Merry Sithmas, my friend. I gave you a shout out, Josh, for sending me this Funko Pop of Emperor Palpatine, the featured Funko Pop. Merry Sithmas, because it is Christmas. So thank you, Josh. But anyway, so just a few more minutes here before we sign off. But the space station is really easy to see if you just follow this information. So get yourself familiarized with about how much a degree or 10 degrees is worth in the sky, in the night sky. You kind of can imagine that on an invisible dome, and then you get a good sense of reading this information and when will it approach, what's the highest point it's going to be, and then when will it disappear. And it's going to be an arc. So imagine that in your head with every single pass that you're going to go attempt to look at. Yeah, so it's pretty easy, just a few numbers and you're on your way. I ended up talking a lot more than I thought. I said I was going to wrap up around 8:30 and we've got a few minutes here. So I'm going to leave it at that. We'll talk about transits another time. I do have some stuff to prepare, but that's okay. We'll keep it simple. Maybe you guys can see us. Oh, excuse me, a Christmas space station sighting. So use this information, go out and look for the space station over Christmas weekend, and then comment below on this video or tweet us. Let us know on Twitter too. If you guys went out and saw something, let me know. It'd be fun to hear about your opportunities and your adventures, and maybe you guys had a good sighting wherever you are in the world. So yeah, with that, I'm going to actually just kind of close things up here. I'm not going to do my normal homework recommendations this week. Just wanted to, again, I figured that would burn too much time. So next week I will be back live on Wednesday night, 8 p.m. Central Time here on YouTube on the Orbital Alliance YouTube channel. And we'll just go back to our usual discussions. Maybe we'll talk about solar and lunar transit findings, sightings next time. And you guys can learn about how that works now that you have some sort of base knowledge with about just how to see a normal sighting. So get some practice in and come back fresh for next week. It's gonna be cool. But yeah, so I had some fun tonight. Thank you guys for joining me. I hope you guys all have a really, really wonderful Christmas weekend. And that you guys are, again, staying safe with all the rise in COVID, infections that are going on. Protect yourself, protect your family, do the best you can. And hopefully everything is well by all of you guys. So, if you're brand new to the channel and this is the first time watching something, would appreciate your subscription if you found that I have earned it tonight and if you learned something. So be sure to subscribe to the YouTube channel by clicking the red subscribe button on the video, and then once you do, the little notification bell will pop up. If you click that, it'll remind you to it'll send you new alerts on your phone or on your computer telling you a new video has been posted or if we're going live at any time. So again, would appreciate your subscription. So cool, everybody. It is, what are we at? 8:29. Yeah, it's time. All right. Well, again, we'll be back just before New Year's Eve next week. Have a wonderful Christmas. Merry Christmas, everyone. See you all on the other side. We'll be back just before New Year's Eve next week. Have a wonderful Christmas. Merry Christmas, everyone. See you all on the other side.